And welcome everybody to our Fields and Features segment. We've got geomagnetic unrest kicking up and some very strong fields to talk about. Let's look at the last 4 hours of Earth's magnetic moment from space as modeled by the Space Weather Modeling Framework. We're going to see some changes happening to the magnetic environment there. You're looking at a scale of nanopascals, which is magnetohydrodynamic density, magnetohydrodynamic pressure, rather. Anyway, that's the last 4 hours. Again, geomagnetic unrest conditions, maybe sparking auroras, possibly induction into power grids. Let's take a look at that from the global perspective. Here's the last 4 hours from the flattened world map. And that'll show you the most likely places for things like viewing the aurora and induction into things like railroad tracks, pipelines, and power grids. Let's show the polar view here as well, since there may be some additional insight gained from looking at the polar view. We've animated that. Quite significant magnetic pulses there, kind of on a global scale. And what you're looking at here on these images is magnetic flux density here at the ground level. And that is nanotesla, by the way, nanotesla magnetic flux density. Next, let's look at the heliospheric current sheet. This is the plasma from the sun. Keep in mind this is not to scale. This data is derived from 51 ground-based magnetometers and magnetometers on stereo here at Lagrange 5 and stereo B at Lagrange 4. There could be a North Pole current sheet speeding our way. We'll have to look at the way sunspots progress, which we'll do momentarily. We've got some new groups having risen. First, let's take a look at the GOES magnetometers. By the way, I brought up the Details tab, and if you don't know what this Details tab states and you look at this every day like we do, you may want to read this because it's a little bit complex what's going on with the GOES magnetometers. Magnetometers in general are interesting instruments, and these are the GOES 16 and 17 are at slightly different locations, which is why they show the N's and M's. So the reason we see these N's and M's, that's noon local time for the GOES 16. This is midnight local time for the GOES 16, giving you some indication just by looking at the graph at a glance where the satellite is located. So we're seeing some strong fields here during this period of geomagnetic unrest. We'll look at things like the solar wind momentarily. First, the line of sight ecliptic plane field plot. Again, there could be a North Pole current sheet speeding this way. It all depends on the way the latest sunspots either degrade or maybe they'll grow. Who knows? What do you think? Let us know in the comments. So here's our line of sight coronal hole plot. Lots of South Pole oriented coronal holes here in the earthly zone, just reaching up to a transequatorial status, meaning they're crossing the solar equator. This also shows you the solar B field in blue. Keep in mind the data is 1 hour and 15 minutes old and can change with essentially no warning. So here's the ultraviolet spectrum in 193 angstroms. Great well-defined coronal hole there, just passing through the Earth-facing zone. We can expect a high-speed solar wind from that in a few days. Now, I don't know why the detected sunspot groups map is not animated. I'm just putting it up here because it is showing the numbers of these sunspots. So we're going to have sunspot 29, 45, and 46 will be these new groups rising over the eastern limb. Likelihood of major flares is still significantly high because we've got sunspot 2941, which has not really degraded much in the past 24 hours. The major groups have mostly remained stable. So this is 2939, which by tomorrow will be set. You can see some additional umbrae there to its south, which have actually grown here. They consolidated a little bit over the past 24 hours. Next, the northern groups, that's 2940 and 2941. We could fit them into the same frame, so we did. And it looks like the leading umbra here is degrading a little bit. We see a little bit of a light bridge forming, at least at the beginning of the video there for sunspot 2941, the most likely place to see major flares. And here's this rising group. This is going to be 2945, I believe. It's already beta class. we could see flares from that. Don't be surprised to see flares from that, especially with its proximity to the solar limb. Slightly higher statistical probability to see a solar flare at the solar limb, especially a major one. We won't get into the physics on it on this video. So here's the full disk view in 1700 angstroms. Let's blast through some more data here. We don't want the video to be too long. So only a minor C-class intensification here happened over the past 24 hours. That was just a few hours ago. No spikes in the proton flux. No surprises to our regular viewers there. And let's take a look at the real-time solar wind to show you what's causing the geomagnetic unrest. Very strong fields. You can see the fields have made it all the way up to a BT of 17 and a BZ of positive 17. If that was 17 with a BZ of negative 17, we would see like a KP6 or 7 geomagnetic storm from that. So if the BZ component, which is this red line, if that suddenly shifts into negative territory and the field stays as strong as 18 nanotesla, that is certainly enough to intensify the geomagnetic unrest. We did see a spike in the solar wind density here, made it up to about 27 protons per cubic centimeter. Current conditions are more like 5.7 protons per cubic centimeter, similar to what we reported yesterday. Solar wind speed only 423 kilometers per second, so it's largely a magnetically induced geomagnetic unrest condition. Here's the past 3 days. You can see there was a brief period of geomagnetic storm there, sort of late in the day yesterday. Next, just a solar system forecast. If you're wondering where Mercury, Venus, and so on will be over the next 7 days. Here's where things will be in 7 days. We will have a gibbous waning moon by that point. We've also brought up a star chart to help orient you. If you've got an alternative explanation for what causes the day-night cycles, something besides a spinning spherical planet, please let us know in the comments. If you're up before dawn, you may see Saturn and Mercury and Venus and Mars all piling up there ahead of the Sun. It's a planetary pileup on the ecliptic, which is this yellow line. The path that you can watch the Sun cross throughout the day. The blue line is the galactic plane, if you were wondering. And we did see a coronal mass ejection. It was kind of a stealthy one. I don't think it's particularly Earth-directed. If it is, it's going to be minor. So here's the view from stereo A and the LASCO C3 located here at Lagrange point 1, stereo A at Lagrange 5. So here's your stereo A, here's your LASCO C3. And it does indeed look a bit like a halo. So you can see coming out of this area, you can see sort of ejecta all around the obscurement disk. But we're also seeing that on stereo A. So this is a bit of an undefined coronal mass ejection, folks. It certainly doesn't look like a major one directed at the Earth. However, we can expect to see additional CMEs here. So we've got some major prominences kicking off. And that's about it for our fields and features section. Thanks for tuning into the segment. Congratulations on realizing the channel exists. Don't forget to press like and subscribe if you enjoy the content. I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network. Least busted name in news, and may that solar wind be at your back.